Hello everybody, Assalamu alaikum. I'm Shohr Rustamov, and today with you we're gonna see some examples and we're gonna learn what is illustrative machine language. In other words, today we're gonna deal with Brookshear machine, what is exactly, and we see some kind of a midterm examples, questions, we're gonna solve them. And today I will teach everything about you, everything about a Brookshear machine, okay? So, first of all, what is illustrative machine language? It has 16 general purpose registers or GPRS with a capacity of 8 bits and reference it using hexadecimal numbers 0 to F. It has 256 memory cells with a capacity of 8 bits and reference it using hexadecimal numbers 00 to FF. So now here you can see this is your central processing unit. You know what is a central processing unit? It's like a processor in your language, and for example Intel Core i5, Pentium, AMD Ryzen, all of them, this kind of stuffs are processor, yeah, oh, CPU. So inside of a CPU there will be register 0 1 2, label it as 0 1 2 to F, for example, and a program counter and instruction register, and your CPU, central processing unit, connected with the main memory using bus. It's some kind of a bunch of cables, bunch of wires that connects between central processing unit and main memory. So what is your main memory? So your main memory is your HDD or SSD hard disk drive or your solid state drive, and it contains address and cells. So each cell has its unique address, and cells contains the data, the informations. Okay, so let's talk about parts of a machine instruction. Each machine instruction is 16 bits long, opcode 4 bits, this is opcode, and operand, which is 12 bits. So once opcode specifies which operation to execute, operand, this 12-bit operand gives more detailed information about the operation. So all of these characters will store it in zeros and ones, using zeros and ones in a computer, inside of a computer, but it is much more easy for us to use hexadecimal form, the hexadecimal uh, numbers using, yes, you know what is a hexadecimal, I guess. So let's see the decoding the instruction, for example 35A7. So 35A7, as we said earlier, the first one is our opcode, which gives us the information about what kind of instructions, what kind of operations we will do. So there is an appendix, call it appendix C. This kind of is a bunch of instructions. For example, if you paid attention, the first symbol, the first character has already given here, and other stuff label it as R, S, T, R, X, Y. So what are they? So for example, if some kind of a code starting with 4 gives us this information, for example, this information, this instruction, so we should do this kind of instruction. For example, in our case it is 35A7, yeah, so it's starting from 3, so we should take this instruction and follow it while we are decoding our code, okay? I mean this guy. So perfect. Now we're gonna see some kind of examples today with you, and you will understand what we will do and what we did more briefly. Don't worry if you don't understand nothing up to here, then now I'm gonna clarify all of them. So the rest stuff will give more detailed information. So let me just jump. So this is the interface, being familiarized with it right now by the professor Sarwar Abdullayev. So basically this kind of example consists two tables. The first table is about your memory. So as I said earlier, inside of a memory there will be addresses and the contents inside of them, and in the register, in the CPU, in the second table, you can see some kind of registers and contents. So what we should do, so we should fill this part, this program counterpart, in this content section if it's necessary, and this content section. So but it's mandatory to fill these two parts, but these parts actually based on our code what we have here, and maybe fill it or maybe just um, left as empty. So now we're gonna see the example, this example, and you will have more understanding. So I have developed this kind of a algorithm for you. I've developed it by myself, taking this kind of problems into consideration. So let's read it. Use a useful algorithm to deal with the Brookshear machine by Rustam. So it contains only 4 steps, just 4 steps, and if you follow these 4 steps, you can do any kind of problems like this. Okay, just use this algorithm. The first step: take the pair of address from memory to get 4 symbol code. Before we start, I want to say one thing. What is program counter? Program counter tells us what kind of addresses we are dealing with right now. So as you saw, it starts from 00, so it means we should start from directly here from 00. Okay, so perfect. So let's start. Take the pair of address from memory to get 4 symbolic code. So we should take the pair of address, which means 2 addresses together to get 4 symbolic code. If we take only one of them, we got only 2 characters, 2 symbols. But in order to execute them, in order to decode them, we need 4 characters. So we should take every time the pair of address, the pair of address. Okay, so let me take the pair of address. So I've taken it, so I'm done this step. So increment the program counter. So I should increment this program counter. Okay, this program counter. So let me increment it. Now we are 00, so if we increment it, it will become 02. Why? Because we are taking the pair of address together. So I should write 02, because after 00, if we add 00 plus 2, it is equal to 0002. Yeah, so anytime if I say increment, you should increment by 2, because we are taking the pair of addresses. Okay, just uh, just write 0.2 here. So we are done this step, we have incremented it, and write down 4 symbolic codes to content section. So we have taken this 4 symbolic code, and so let me write down in the content section. So BOFO. Yeah, is it BOFO? Yeah, it is. So the next step, so we have done this step, and decode this 4 symbolic code and implement it. So let me go and implement it. So let me write down what is the code. BOFO. Yeah, so let me write it down here. So BOFO. Perfect. So as you saw here, our first character tells us what is our opcode. So our opcode in that case is B. So let me find B. First of all, search opcode from this appendix. This kind of appendix will be provided in your exam by the professor. Don't worry, do not try to memorize it. Okay, so let me find B. Oh, B is here. Yeah, B is here, and there is written B RXY. Yeah, so our R is 0 in that case, our X is F, and our Y is 0. So let me read and understand the instruction. So after you found the opcode, you should understand what it tells us, what kind of instructions it contains. Okay, so let me read it. Jump to the instruction located in a memory cell at address XY if the bit pattern in the register R is equal to the bit pattern in the register number 0. Otherwise, continue with a normal sequence of execution. So what it says to us, we should compare the bit pattern inside of R register with the bit pattern in the register number 0. So in our case, what is R? R is equal to 0. Yeah, our R is equal to 0 and our xy is equal to f, oh sorry, let me use my screen. Okay, fo, our xy is equal to fo. So basically, if our register is our r is equals to 0, so we should compare 0 register with 0 register. So it is true. It's a true statement. Why? Because a bit pattern inside of a 0 register is equal to the bit pattern in register number 0, because they are same registers. Come on, guys. If you compare the content inside of a 0 register with a 0 register itself, you got a true statement, because 5 is equal to 5, for example. But we are not comparing the register numbers. We are comparing the content inside of it. We are comparing the content inside of it. So if the registers are the same, so the content inside of them are also will be same. Okay, that's why that is true statement. If it's true, what we should do, we should jump to xy location. So xy address is, so it's f0 in our case. So let me jump here. So let me erase this. So guys, where is f0? It is here. It is here. And one rule, guys, if you jump to some kind of a location, please do not forget any time to write down the jumped location immediately to your program counter. So in that case, it is f0. Anytime if you did jumping, write down this address here. So let me erase this stuff. So now we are at f0. So let's back again and follow this 4 steps. So take the pair of address to get 4 symbolic codes. So let me take the 4 elements, this one, the pair of elements, sorry, and increment the program counter. So our program counter is f0. So let me increment it. If we increment it, we got what? f2. So then write down 4 symbolic codes in the content section. So let me write down the code 2000 with comma here. Perfect. And decode this 4 symbolic code and implement it. You can see we're gonna take we will repeat this code again and again. We will repeat this algorithm again and again once we faced with C000. Okay, repeat these 4 steps once you get C000, which means stop and halt the execution in the first step. So in the first step, while we are picking this 4 symbolic code, if you see C000, you should immediately stop and do the rest of stop. Then write C000 in content section and cross the last address in program counter. Okay, we're gonna see it at the end of our video. Okay, and while you are decoding, if your code requires to change some values, always update them and use the new values in next steps. Okay, guys. Now we have done writing down this 4 symbolic code in content section here 2000. So in the 4 steps we should do decode it and implement. So let me decode it and implement it. So here, let me erase all stuff here. So 2000, yeah. So 2000. So our opcode is 2. So let me go and find 2 from here. So it is here, yeah. Perfect. So what it says to us, load the register R with bit pattern XY. So we should load the register 0. There's 0. Load the register R. So load the register 0 with a bit pattern XY. So XY in our case is 0, 0. So we should load the register 0 with a bit pattern 0, 0. So let me load it with the new value. So let me use my screen. 0, 0. Okay, we have loaded 0, 0, yeah. So we are done. We have decoded and implemented it. So now we are f2, yeah. We are now f2. So let me erase this stuff, and now we are in f2 here. So let me go and see. Take the pair of address from memory to get 4 symbolic code. So let me take the 4 symbols or 2 addresses together. Then increment the program counter. So let me increment the program counter. So it will become F4. So go here. After incrementing program counter, write down this 4 symbolic codes to content section. So let me write down this code in this content section. So it is 2202. Perfect. Then decode this 4 symbolic code and implement it. So let me decode and implement it. It was 2202, yeah, 2202, yeah, 2200, oh sorry, 02, 2202. Perfect. So our opcode is 2 again. So let me go 2 from here. It says load the register R with the bit pattern XY. So we should load the register R. So in our case it's 2. So let the register 2 with the bit pattern 02. So let me load register 2 with the bit pattern 02. So it means I should just write 02 in here. Now it means inside of a register 2 there is a bit pattern 02. Now we are done. So don't forget they are in hexadecimal. So I have decoded and implemented it here. So let me go again. Not sorry. Now we are at F4, yeah, this F4. So let me erase this stuff. Now we are at F4, this F4. So now we will start. Take the pair of address from the memory to get 4 symbolic code. So let me take the pair of addresses from here, which is 2304. Okay, increment the program counter. So let me increment the program counter. So let me increment it, F6 it will be, yeah. Perfect. Then write down this 4 symbolic code to content section. So let me write down this 4 symbolic code, 2304, yeah. And 4th step, decode and implement it. So 2304, basically 2304, 2304. So again its opcode is 2. So let me go 2 here. Okay, 2. Load the register R with a bit pattern XY. So we should load the register, load the register 3 with a bit pattern 04. So let me go and find the register number 3. It is this register. And so let me write 04 XY, yeah, 04 here, 04. Now perfect. So I written down 04 to start the register, means I have implemented the code. And now we are at F6, yeah, we are here. So let me erase this stuff. Now we are at F6. So let me do this again. Take the pair of address. So let me take the pair of address to get 4 symbolic code. We got the 4 symbolic code, yeah. Then increment the program counter. So let me increment the program counter. So it will be F8 if we increment F6 by 2. Okay, then write down this 4 symbolic code in the content section. So let me write down this code B3FC to the content section. Now we are done. Perfect. Then decode and implement it. So let me go and decode and implement it. B3FC. So B3. So B3FC. So our opcode is B, not 2. So where is B? First of all, let me find B. Oh, B is here. So B is here. Then what it says, jump to the instruction located in XY if the bit pattern in R is equal to bit pattern in 0 register. Yeah, so in our case R is equal to 3, which means we should compare the bit patterns in 3 register. Yeah, in R register, so R is equal to 3 as I said, with the bit pattern in the register 0. So let me go and see. So in the register 0, we have 00. In the register 3, this register 3, we have 04. So 00 and 04, this are these things equal to each other? No, they are not equal, which means we got false statement, which means we won't do jumping here. So as written here, otherwise continue with the normal sequence of execution. So we just keep implementing the code in the normal sequence of execution, so no jumpings here, guys. Okay, if there is no jumping, so let's come back again and see the next steps. We are at F8 now, so let me delete them, and now we are F8 here. And so let me implement this algorithm again. So take the pair of addresses to get 4 symbolic code. So let me get 4 symbolic code starting from F8. Okay, then increment the program counter. So let me increment the program counter. So it is FA. Why FA? Because if we add 8 plus 2, if we add 8 plus 2 is equal to not 10 but A, because we are using hexadecimal. Okay, I think it is easy. So anyway, FA is here, this FA, I mean. So we have incremented program content and write down this for symbolic code in the content section. So let me write down this for symbolic code 5002 here. Perfect. Then in the fourth step, decode and implement it. So let me go to decode and implement it. 5002, yeah, 5002. So 5002. So our opcode is 5. So let me go and find 5 here. So 5 is here. So these guys, let me erase them. So 5 is here, and what it says, let's read together. Add the bit pattern found in register S and T as though they were 2's complement representations and leave the result in register R. So instead of SAT, we have 0 and 2. Instead of R, sorry, we have 0, yeah? Instead of this R, I mean here. And this stuff, guys. So what we will do, we should just add the bit pattern found in register S and T. We should add them. So let me go and find 0 register. So it is this register, and let me go and find T register, which is register number 2, which is this register, and we should add the bit patterns inside of them, which means we should add 0 by instead of second register, it's 2, yeah, 0 2. So we get what? We got 2 or O2. And what we should where we will save it, we will leave the result in register R. Instead of R we have 0, so we should leave this result in the register 0. So let me go and update a value. So let me write 0 and 2. Perfect. So these are not necessary, so let me erase them. So now we have decoded and implemented, yeah? Perfect. So we have implemented it, and now we are at FA, yeah? So we are now at FA. So let me delete this stuff. And so let's see our algorithm. Take the pair of address. So let me take the pair of address, which is BOF6, this one. Then the next step, increment the program counter. So let me increment the program counter. So let me put comma here and increment the program counter with FC. Yeah, let me put comma again. Okay, not necessary. And okay, we have incremented program counter. Then write down 4 symbolic code. So let me write down a 4 symbolic code in content section. So the 4 symbolic code is BOFC. No, F6. Sorry, BOF6. BOF6. And next step, decode and implement it. So let me go and decode and implement it. So BOF6, yeah, BOF6. So BO. So BOF6. So our F code is B, opcode is B. So let me find B from here. So B is here, and so let me read the instruction. So jump to the bit instruction located in memory cell at address 6y if the bit pattern in register R is equal to the bit pattern in register number 0. Otherwise, continue with the normal sequence of execution. Okay, it says if your bit pattern in register R, in our case it is 0, is equal to the bit pattern in register number 0, jump to location XY. So guys, as we saw earlier, the inside bit pattern inside of a register 0 is always equal to the bit pattern in register 0, because we are comparing the elements inside of 0 register with this 0 register. So it is always true, it is always right, they are always same. If you saw some kind of a opcode starts from, if you see some kind of a code starts from B0, then some kind of a XY, never forget, you will absolutely jump to XY location. Why? Because according to the instruction, you are comparing 0 address, 0 register with 0 register. Yeah, but if it says B1XY, for example, you should go to the first register. So you should go to first register and see what is inside of it, and go to 0 register and see what is inside of it, and you should compare these two guys. Okay, this is just a simple English. If your comprehension is better here, you will understand what we have done here. So now it's time to jump F6, because we got the true statement. So let me jump to F6. Where is F6? F6 is here. F6 is here. So now we are here. So as I said in the beginning of the video, if you do jumping, please write down the value immediately to your program counter. So now we are at F6. So let me go and see. Sorry. Yeah, okay. No, forget about it. So F6. Let me go and see. Take the pair of address. We have taken the pair of address. Then increment the program counter in the second step. So let me increment the program counter via F6. So if we increment it, it will be F8. Then I write down 4 symbolic code in content section B3F3, which is so B3FC. Perfect. Then in 4th step we should decode and implement it. So let me go and implement it. Oh, sorry, let me erase all of the stuff here. They are not necessary to us. What we got? B3FC, yeah, B3FC. So let me write B3FC. So this is our new code, and let me decode it. So its opcode is B, so let me go and find B here. So it is here. So again, it says compare the patterns in register R with the bit patterns in register 0. In our case, register R is equal to 3. So let's see what is inside of 3 register. This is 3 register number 3. So inside of it's 04, but inside of register number 0 there is 02. In your opinion, is 04 is equal to 02? Absolutely not. So it is false statement. So means we won't do jumping here. Yeah, we won't do jumping. So no jumping. Height. Then we will keep the normal execution. So now we are at F8. So now we are at F8. So here it is F8. So let's come back again and see. Right. So let me take the pair of address. First step. So take the pair of address. It is 5002. Then increment the program counter. So let me increment the program counter. So it will become FA because we are incrementing F8 by 2. So we're done the 4 symbolic code in content section. So let me write down this 4 symbolic code in content section. So 5002. Now it's good, yeah. 5002. So now we have written the code in content section. So let me go and decode and implement it. So let me erase this stuff. So 5002, yeah. So 5002, good. So our opcode is 5. So let me go to and find 5. So 5 is here. So let me read it. Edit pattern found register S and T as though they were just completed representations and leave the register in R. So it means this instruction means we should found the bit patterns inside of S and T register, and we should add them, and we should leave the result in this register, which is data register. So let me find which first S register. So our S register in our case is 0. Yeah, it is 0, and T register is 2, this register. So we should use a new updated values. Yeah, so we should add 02 plus 02, which is 04. So and the result is 04, and we should leave the result in register R. So according to our code, our register R is 0. Yeah, so let me update the content in 0 register. Let me write down 04. Now good. So I can delete them, it's not necessary anymore. So we have implemented, and so let's go to the next step. Now we are at FA. So now we are at FA. So let me clear this. Now we are at FA, and so let me go here again. Take the pair of address to get 4 symbolic code. Let me take the pair of address, which is BOF6. Then we have taken it and increment the program counter. So let me increment the program counter. So after FA it will become FC. Good. Then I've incremented it. Then we're down this 4 symbolic code in content section. So let me write down this code in here. So it is BOF6. Good. Then the code and implement the code. So BOF6, yeah. So BOF6. So it is BOF6. Good. So our opcode is B. So where is B? B is here. It says what? Jump to the instruction. So we should jump XY address if the register R and the bit pattern inside of it is equal to the bit pattern inside of register number 0. So basically R in our case is equal to 0. Yeah, so this is equal to 0. So we are comparing a bit pattern inside of a 0 register with a bit pattern inside of a 0 register. So if we compare the bit pattern inside of a 0 register with a 0 register, because they are the same register, we got true statement. Yeah, because now inside of 0 register there is 04, and inside of 0 register again 04, and 04 equals to 04. So anyway, as previous examples, is true. So we should jump just F6. So where is F6? Come on, F6 is here. So let me erase this stuff. And so we are now at F6. As I said earlier, if you jump to some kind of a location, immediately write down its value. So now we are at F6. So let me go and implement algorithm again. So we should take the pair of address starting from F6. So I've taken them. Then increment the program counter. So let me increment the program counter. It will become F8. Then write down the 4 symbolic codes to content. So let me write down the code. The code is B3 FC. Good. Then we should decode the code and implement it. So B3 FC again. Yeah, B3 FC. So B3 FC. So what we will do, so our opcode is B. So let me go and find B. Okay, B is here. So we should compare the bit pattern inside of our register and the bit pattern inside of register number 0. And if it's true, we should jump to the address XY. Otherwise we should keep it normal. Yeah, so in our case our register is 3, so let's go and see what is inside of it. So in the 3 register there is 04, and inside of register number 0 there is 04 again. Oh, kabam. Is 04 is equal to 04? Yes, they are same. So it's true statement, which means we should jump to the location, jump to the address FC. So let me jump. So sorry, let me jump. Where is FC? FC is here. So once we jumped, so don't forget, immediately write down the code FC, jump location. Now we are FC, we have implemented it. Now we are FC, and so let's implement our code. Take the pair of address. So let me take the pair of address. Now it is C000. Oh, it is C00. Wow, which means after this asterisk, what I've written here, repeat these 4 steps once you get C00 in your first step. Now in our first step we got C00, so let's keep reading. Then write C00 in content section. So let me go and find a content section and write down C00 here. So C000. So then cross the last address in program counter. So let me cross out the last address in a program counter. I've crossed them, and so this is the end of our problem. That's it. If you read here, C00 is halt execution, and we halt the execution, we stop the program, and the program stops there. Okay guys, now we have discussed about how to deal with the Brookshear machine. I think after this video you will become a master of Brookshear machine problems, because I've tried maximally explain everything in detail. I try to elaborate it, and that's it. That's the end of this video. So thanks for your watching. Today Shahrukh Rustamov explained lots of things to you, try to explain his new algorithm. Of course, this algorithm is created by me. This new algorithm, and you can use it to solve this kind of a problems. Okay, so just use it, and please never stop supporting our academic support club. If you liked the video, please uh, press the like button. If you have any kind of questions, leave them in comments below. Rahmat hammaga sog' bo'linglar. See you soon in the next videos, next tutorials, inshallah.